Okay, hello again. This is the Chapter 2 test on page 122 in the textbook. So again, the same kind of things apply. Hopefully you do this before you're watching this video, but if not, it's your choice. So number one, rather than writing this one out, this says determine whether these relations represent a function. Remember, for a function, you need to have, each input needs to have only one output. So if you look at the first one, we have 2 mapped to 5, 4 to 6, 6 to 7, 8 to 8. So in that one, each input has exactly one output. So the domain would be 2, 4, 6, and 8. The range would be 5, 6, 7, and 8. For B, we have 1 mapped to 3, 4 mapped to -2, -3 mapped to 5, and 1 mapped to 7. So we have 1 getting mapped to 3 and 1 getting mapped to 7. Since the input of 1 has 2 outputs, B would not be a function. Number C, or part C, we can use the vertical line test because it's a graph. Does not pass the vertical line test, so it's not a function. And then D does pass the vertical line test, so it is a function. It looks like on part D, the domain is all reals. It looks like you can plug in any number. And for the range, it looks like you can get anything from 2 up to infinity. It looks like including 2. That's tough to tell from the graph there. The domain for this one would be everything from -1 to infinity. The range would be all reals. And I think you guys can figure out, maybe I left some of those other ones blank, but I think you guys can figure those out. Number 2. So for number 2, we want to find the domain and evaluate at x is equal to -1. Remember, when we take a square root, the thing in the square root has to be greater than or equal to 0. So 4 minus 5x has to be greater than or equal to 0. I can just bring the 5x over, divide by 5, so x has to be less than or equal to 4/5. And so the domain would be -infinity to 4/5. And I can include 4/5 because of the equal sign there. So that would be my domain in interval notation. F of -1 just means I plug in -1. And 5 times -1 is -5. 4 minus -5 is 9. Square root of 9 is 3. Number 3. No square roots, but we can't divide by 0. So the absolute value of x plus 2 cannot equal 0. And really, the only way that this thing is going to, the only way that that left-hand side is going to equal 0 is if x is -2. So x cannot be -2. So the way we'd write that domain would be -infinity to -2, not including the -2, union -2 to +infinity. So all reals except -2. Or you could write it this way. You could say all x's such that x is not equal to -2. So in set builder notation, sometimes the book writes it that way. And g of -1 is, we put in -1 plus 2 and -1 plus 2, an absolute value in the denominator. So that's +1 over +1, which is 1. Bottom one, we may want to factor the denominator. And we're looking for the factors of 36 that subtract to give us +5. And so it's +9 minus 4, I think. And so in this one, the denominator again cannot be equal to 0. So x plus 9 times x minus 4 cannot equal 0. So x cannot equal -9, and x cannot equal +4. So in this case, the domain would be all reals except -9 and +4. So this way, like so. And I don't remember the name of this function, maybe it was f. So f of -1, just put in -1, so it's -1 minus 4 divided by -1 squared plus 5 times -1 minus 36. So you get -5 on top, and 1 minus 5 is -4. -4 minus 36 is -40. And so the negatives cancel, and it's 5 over 40, or 1 over 8, 1/8. If I did my, oops, that over. If I did my arithmetic correctly, it should be 1/8. Okay, number 5 is another one that we may want to take a look at the graph in the book real quickly. So the domain is, looks like we can put everything in from -5 to +5. In the range, we can get out everything from -3 to +3. So the domain -5 to +5, including the endpoints. And then the same thing for the range, -3 to +3. The x-intercepts, -2, 0 and +2, 0. Those are the x-intercepts. The y-intercepts are, is 0, 2. You just look on the graph, crosses at 0, 2. F of 1, if you plug 1 into the function, you come out with 3. And that's because there's an ordered pair. If you take a look at this. The 0.13 is on the graph, so that means if you put in 1, you come out with 3. So f of 1 is equal to 3. Part D, it says, for what x does f of x equal -3? Well, the function is equal to -3 at 2 different points, so the answer would be -5 and +3 both. So x equal -5 and x equal to +3. So both of these would be solutions here. And then part E, it says solve f of x. Basically, you're looking for the values of x that make the function negative. And if you look at this, the function's negative here and here. So the x values that make that happen are from -5 to -2 and from 3 to 5. So the solution here would be -5 to, what did I say, -2. And at -5 it is negative. At -2 it's actually not negative. It's actually equal to 0. Union 2 to +5. So at +5 it's negative, but at 2 it's actually not, so we don't want to include the 2 there. Number 6, we want to find the local maxima and minima of this particular function, then where is it increasing or decreasing. If I move this down, you can see it now. So what you want to do is go ahead and plug this -x to the 4th plus 2x cubed plus 4x squared minus 2. Plug that into your calculator, and we want the window to go from, maybe I'll put this up here. Sorry. We want the window to go from -5 to +5. So I should went into window, and then put -5 to +5, and then push graph. two functions in here. Let's see, we may need to zoom out here for our y's. So the y, let's go to like negative 20 to positive 20. Make sure I put this in right. Ah, that's the problem. Negative x to the fourth plus 2x cubed plus 4x squared minus 2. Yeah, if you put the equation in wrong, that's going to make a big difference. Right, so that looks a little bit better. And so if we take a look at the graph of this function, it looks like there's a local max here, a local min here, and a local max here. And this actually might be a global one as well. But to go ahead and find those, recall what we do. So we go in that calculate menu and find minimum. Give it a left bound and a right bound and a guess. So we have a local min at, by the way, when it gives you negative 2.05, e negative 6, that's scientific notation. So that's basically, you're moving the decimal place over 6 places. So it's a decimal point, 5 zeros, and a 2. So basically that's, people call that a machine zero. It's like a calculator's version of 0 pretty much. So that's 0, negative 2. For all intents and purposes, around the 2 places, it's definitely that. A max, local max. So go to the left, hit enter, go to the right, hit enter, give it a guess, and it looks like that's negative 0.85, comma, negative 0.86. And we'll do the other one as well. So we'll go just to the left of it and push enter. Just to the right of it, push enter, give it a guess, and the guess doesn't really matter a whole lot. And it looks like that's 2.35, comma, 15.55. So this is how we write our local max and min. Determine where the function's increasing and where is it decreasing. So if we look at the graph, the function seems to be increasing here, decreasing, increasing. So increasing on this interval here, and increasing in this interval here. So that looks like it's increasing from negative infinity up to, what was that, negative 0.85, I think was the x value. And then from 0 up to 2.35. So that's where the function's increasing. And decreasing is in the other spot. So negative 0.85 up to 0, union 2.35 to infinity. So that would be the answer there. Number 7. We've got a piecewise defined function. It just basically means for different x values, you plug some x values into the top of one, some x values into the bottom one. And so for the graph, basically what we're going to do is just kind of split this into two. And so if this is negative 1 right here, if this is x equal to negative 1, for everything left of x equal to negative 1, we're going to use the top function, 2x plus 1, And for everything to the right, we're going to use x minus 4. So, because it's greater than or equal to negative 1. All right, so y equals x minus 4. It has a y-intercept of negative 4 and a slope of 1. So basically it's going to look like that. And notice that I want to put a closed circle here at negative 5 to indicate that the function actually is equal to that. And that's because at negative 1, that means you use this function. So just draw that line right there. It doesn't keep going. It stops right here because on the left side of this graph, we're going to use the other function. And so 2x plus 1, it has a y-intercept of 1. We're not going to graph that point there. And a slope of positive 2. So that means you go down 2 to the left 1, down 2 to the left 1, and keep going like that. Slope of negative 2. Let me do that again. Slope of negative 2 would mean we go up 2 to the left 1, up 2 to the left 1, like that. So this is a slope of negative 2. So this one has a slope of negative 2. Notice it would have a y-intercept of positive 1 and keep going down. But we use this line over here. Notice I put an empty circle here because at this one we don't actually evaluate it at negative 1. Intercepts, it has an x-intercept and it has a y-intercept. The y-intercept is easy. It's 0, negative 4. And the x-intercept, we just need to find this point right here where it's crossing. And we use the x minus 4 function because that's what this is. This is y is equal to x minus 4. And so just put in 0 for y and x is equal to 4 there. So 4, 0. G of negative 5. We're going to find g of negative 5 and g of positive 2. G of negative 5 we plug into the top one. So it's 2 times negative 5 plus 1. So you get negative 10 plus 1 is negative 9. And then g of positive 2 we plug into the bottom one because that's a number bigger than negative 1. So I put in 2 minus 4, which is negative 2. Number 8, they give us a quadratic function, and we're supposed to find the average rate of change of f from 3 to 4. Okay, so we need to find f of 3 and f of 4. So f of 3, that means I just plug in 3. 3 squared is 9. 9 times 3 is 27. Minus 2 times 3 is 6, plus 4. So 27 minus 6 is 19, so this is 23. And f of 4 is 4 squared is 16. 16 times 3 is 48. Minus 2 times 4, so minus 8, plus 4. So 48 minus 4 is 44. Okay. And so basically what we're going to do is just find the average rate of change. And so the average rate of change is equal to, it's basically just a slope. So the change in y is 44 minus 23, change in x is 4 minus 3, and so you get 21 over 1, so the slope is 21. Alright, and number 9, they give us a function f and a function g. F minus g is 2x squared plus 1 minus, now you have to distribute the 3x minus 2. Common mistake there is to not do that. So you get 2x squared minus 3x, and then 1 minus negative 2 is 1 plus 2 or plus 3. So that's the function there. F times g, use FOIL, 2x squared plus 1 times 3x minus 2. And we get 6x cubed minus 4x squared plus 3x minus 2. So that would be f times g. And then part C, f of x plus h, do it down here. F of x plus h would be 2 times x plus h squared plus 1 minus f of x, which is 2x squared plus 1. And again, put that in parentheses. Here we want to FOIL this out and get x squared plus 2xh plus h squared. And minus 2x squared minus 1. Use the distributive property, we get 2x squared plus 4xh plus 2h squared. The plus 1 and the minus 1 cancels, so we get minus 2x squared. So the 2x squareds cancel as well, and so we have 4xh plus 2h squared. Like so. Number 10, we want to graph the following. Going step by step. If we just look at the cube function, this is the cube function. Okay? If we multiply that by negative 2, well, the negative means it's going to flip upside down, and the 2 is going to stretch it, which it's hard to draw that. So maybe that's multiplying by negative 2. And then plus 1 and the plus 3, this is going to be a vertical shift, so it's going to move it up 3, and this is going to be a horizontal one, and it's going to move it to the left. And so our final graph of this thing will be like this. If I can put this all together. This is kind of like my new origin right there, and it's the same basic thing, kind of like that. And if you wanted to, you could take a look at your graphing calculator and graph that just to kind of verify. That's so that's shape's a little bit different, but it's in the same place. And again, I'm not an artist, but I do the best I can. So, part B, sorry, forgot one. We're dealing with the absolute value function. Recall the absolute value function is the V-shaped function like that. And so we're basically going to move this 4 to the left and up 2. It's kind of like the new origin. And if you wanted to, you could graph that one as well. I think the absolute value is math. ADS. What is it? X plus 4. Plus 2. So, yeah. Looks basically the same as what we've got there. Number 11, we're given a function, and we want to know in what year was the rate the highest. So I think I've already got this function in here. Our window, we want to go from This is 92 to 2007. So it's like 0 to 15 for the x's, and for the y's, it's a rate, so maybe 0 to 10 or something maybe. Oops. So this is our function. If we want to know where this is the highest, we go to find the maximum, and so we need to go just to the left of it and push enter, to the left of that maximum. Then go just to the right of that maximum and push enter, and then give it a guess. So the maximum is 5.14, 8.67, yes. So that's our maximum. That means it's year 5.14. And so basically that means 5 years after 1992. So 93, 94, 95, 96, 97. So that's just sometime in 1997, if I did my arithmetic correctly. And the 8.67 is the actual rate. So in 1997, rate was 8.67%. Estimate the rate in 2010. Well, you don't want to put in 2010 to the function. What you want to do is figure out what number you should put in. So if 1992, figure out how many years past that we are, and it would be 10 years to 2002, so what, 18 I guess? So you're finding R of 18. And hopefully I'm doing my arithmetic correctly. The easiest way to do this is just to go back to your home menu. Notice that we have this in the function y1. So you could just do it by hand, or you could, there's a bunch of ways you could do it. But if you go vars, y-vars function y1, parenthesis 18. So notice that to get that I went vars, y-vars function y1. That just tells you that's negative 10.343. Does this value seem reasonable? Well, the answer is no. Can't have a negative percent. So what that means is this model we're using probably is not going to be a good one, at least for those values of x. Number 12, we've got some sort of an ice hockey rink, and we're going to let W be the width. We've got a rectangle and two semicircles on the side, and we want to express the volume as a function of the width, where the length of the rectangle is 20 feet less than twice the width. So if the length is 2W minus 20, and this is the width. And so remember, the volume is just, since the ice is 0.75 inches thick, it's just 0.75 times the area. And the area is going to be the area of a rectangle is length times width, so width times 2W minus 20 plus the area of the semicircle. And remember, if we put both those semicircles together, it would be a circle, and so that would just be the area. That would be pi times the radius squared. So pi times, and the radius is W over 2. And so, I don't know how much you can clean this up. There you go. I guess that would be an expression. I don't know how much you could really do with that. I guess you could clean up a little bit. I don't know how my math lab would want that, but we could distribute and combine a few like terms. You could combine the W squareds, I guess. But there's not really a whole much more you can do with that. If the ice in the rink, if W is equal to 90, so meaning if that width is 90, how much ice would be there? Well, the volume would be equal to 0.75 times 90 times 2W, so it's 2 times 90 minus 20 plus pi times 90 over 2 squared. And so maybe what you want to do is just plug that into TI. So 0.75 times, make sure you put your parentheses there, just use 3.14, go ahead and use the little pi button, which is there. So it looks like 15,571.29, and that would be in cubic feet. Okay, as always, please email me or contact me if you have any questions, corrections, anything like that. Thank you.